Alrighty, so I need to go through analyzing results with all of y'all, because that is a critical skill that we need to have. We need to be able to look at our results screen and tell whether it is valid, and I'm hoping you can tell what I've done wrong here, because it is wrong. And this is what you're going to need to do for, I think it's task 3, is look at your solution screen and determine whether or not what you've done is valid, and then solve again. So, let's look at what I've done. As we can see, there is a very strong vertical reaction being applied to this rear, let's call it rear right dropout. This node here, right? And it seems that there is no, or at least it's dissimilar on this side, so that's a problem. There's also a really big twist to the right. I think that's on axis. I mean, of course, that's not absolute scale. I don't think it wants to let me change the scale right now, but as you can see, we've got a big twist. Now, is that valid or invalid? I don't know. I mean, I do know, but you need to think about whether or not that's valid. So let's carry on, shall we? So, as I can see here, having just one reaction there and no reaction there is invalid. So let's look at our supports. And as we can see, I've neglected half of it. That's a problem. Let's change that. Click, control, click. Yep, apply. Now it's on 2 vertices. What a great time. Solve. So what I did there was just look at the geometry and the deformation of our structure and determine whether or not it seemed right. Now, of course, it's kind of hand-wavy to be eyeballing it like this, but there is a skill to eyeballing FEA results and determining whether or not they are correct. You need to think about the forces that go through the structure and the way it would deform logically. So, for example, in this case, we knew that it was going to have a vertical force on the rear wheel, which needed to react the weight of the rider. Now, I've got a fixed rotation up here. I've got a fixed rotation, but do I have any displacement reactions on the front of the bike? I don't think I do. What axis is that not rotating about? So I've got a fixed rotation XYZ. Okay, so it can't rotate around any of those. Right, but it can displace, which is not optimal. Right, so let's try and make this constraint system a little bit more valid. I have solved it, so let's look. Yeah, so that's looking, I mean, super deformed. Can I make that less deformed? Jeez. But that's at least similar between the two sides of the rear dropouts. So that's good. Let's look at, so I've got my total deformation in meters, which is a bit rich. So let's change that to millimeters. So I've got 1.2 millimeters, and I mean, so what we're seeing here is there's no deformation here, no deformation, and then it's being pushed down a heap at the bottom bracket here, and then the rest of it is also deforming out here. So like a lot of our deformation is coming in here, right? Which makes sense because I don't have a compression member in here, which of course you would normally have in a bicycle. As we said, you can just have whatever connection beams you want. Just be aware of how that's going to work out in terms of your deformation and stiffness. So, I'm thinking that very large deformation probably means that I should have something up here reacting vertically. I don't know, maybe I should, maybe I shouldn't. Let's think about it. Should I have a reaction for that front wheel, and if so, should it react in any other directions? Also, why did I put on that fixed rotation on here? Why is a fixed rotation the best way to do that? Is it the best way to do that? These are questions that you will have to answer in your tutor interview and in your final submission. So what I'm going to do, which might be the best thing to do, is to apply a vertical reaction, a vertical only reaction to this node. Yeah, I like that. In fact, I'm actually going to change these two reactions that we've already got, and I'm going to make them only reacting in Y, because it's going to make our analysis a bit more interesting. Now you'll note that it's actually currently free in the X and Z directions, which is not so good. So I'm going to need to react it somewhere in the X and Z directions, because there will be X and Z forces. And this is a critical thing to note in your analysis. So even if in your head you think there are no X and Z forces, sideways and forward and backwards, your model must be constrained in those directions. Otherwise you get infinite displacements from minuscule forces. So keep that in mind. So what I'm going to do is I'm going to do a displacement. I'm going to put it there. Yeah, I like that. And I'll just fix it in all directions. Now, yeah, okay, that seems reasonable. Oh, I need to select a geometry. All right, let's see how that plays. So as you can see, there's a lot of different ways that you can do this that are seemingly right. And especially for a bicycle, because it's actually under-constrained in terms of this kind of analysis. It's very difficult to get a very good constraint case on a bicycle, which is why we chose it, in part, because you need to think about the constraints that are being applied to your bike frame and whether or not you're reacting your forces properly. So let's look here. So now what I've got is a bit more displacement on this right chainstay, which I would expect because there's a tension force being applied due to the chain. So it's being pulled up a bit by a chain member that's pulling it here. So let's just look at our forces. So I've got a downward force there, which is from the right pedal, and I got an upwards force there from the left pedal, which is reacting it. I got a backwards force on that node, on the outermost node. Yeah, that's right. And I've got a downwards force there from the weight of our rider. Now that's interesting, because what that's doing is it's pushing down like that's not in a vertical direction. That's interesting. Is that correct? Well, I did apply it so that it had acceleration due to the rider, but I have a feeling that that's not entirely correct. Anyhow, let's take a look at the rest of our structure, shall we? So now, these two are actually capable of reacting moments by applying a couple. I'm just wondering whether or not I should have the moment reaction up here. Let's look at our solution again. This is why we can't really have you guys competing for lowest or the greatest stiffness, because your load case makes an enormous difference, and we want you to be thinking about your load case. So this is important. So that deflection there, does that make sense? Does it make sense for it to be bowing out to the left when we are applying a force on the right? So let's think about it. So I'm pushing down on this side, I'm pulling up on that side. I've got a tension, or I've got a force pushing backwards there, and it needs to be reacted in moments up here. So it's pushing back there, and our moment reactors are kind of twisting it. So they're reacting it in the y-axis, and if you do your right-hand rule, that's a positive y moment being applied here to react what is effectively a negative y moment down here. So does that make sense that they're deflecting over that way? I think it does. I think it does. So how much stress did I get? Maximum stress, direct stress. So these maximum, direct, and combined stresses are all subtly different. So I've only got 5 megapascals, 13 megapascals. Very low. Very low. Now, something's weird because I would have expected my highest stress to be down here, where all the forces are applied. But I guess I optimized it with a different load case, so perhaps it makes sense. How much does this whole thing weigh? Properties. 4.6 kilos. That's pretty heavy for a bike frame. Pretty heavy for a bike frame. Rightio. The point is, you need to be thinking about these displacements, rotations, forces, and the way that everything's reacted through the bike, because there's any number of ways that we can model this with these constraints, and whether or not we're doing it properly is somewhat challenging. So the way I've done it here is I've said that the handlebars, so old mate pulling up and down on the right and left sides of the handlebars, react moments, but that only necessarily applies to the X direction. So what if I choose my fixed rotation and I only fix it in the X direction and I make these two free, well then what happens to the other two moments, right? So I'll definitely have a Y moment because it'll be reacted, something needs to react the force that's being applied down there, but it shouldn't actually have a moment because the chain is being applied there. So we've kind of got this weird thing going on where the moment down here is being reacted up here, but it's actually that moment doesn't actually exist because it should be reacted directly along here. So what I'm going to do actually is I'm going to fix, okay, Control Z, I'm going to fix in the Y direction this one, this guy, because the moment there should be minimal. Yeah. You can see that this is challenging, right? Like, even I'm not entirely sure what the precisely correct way of modeling this is. But I'm just going to throw on a fixed support there because it's cheap and dirty. I'm not sure if this is going to mess it up because I've put two supports on the same node. It might. Oh, it liked it. Cool. Right. Whoa. That's fun. Whoa! That's wild. Look at that. Okay. Interesting. Whoa. That's insane. Okay. It's so warped. Please let me change the displacement scale. Okay. Let's look at our stresses. Very low. Heaps low stresses. 12, 5, 7 megapascals. Heaps low. What's my deformation? 0.1 millimeters. 0.1. That's nothing. Like, I feel like this is wrong because I know that my bike would deform more than 0.1 millimeters when I'm riding at full tilt. So I feel like I've done something incorrect here. But what? How wild is that deformation? That's crazy. Alright. So I've got a fixed reaction there, which is reacting that torque. And then I've got a vertical displacement there. I've got... So my maximum displacement is actually here. It's actually there. Which is 0.1 mil. That feels wrong. That feels very wrong, doesn't it? So having this reacting the rotations there is very wrong. So we're going to delete that fixed support. We've only got a minute left. We're going to delete that fixed support and we're going to replace it with something different. So I'm going to need to put in, I'll need to put in something that reacts a Y moment. Hopefully I can do this in the time I have. Fixed rotation. 1. Y, X, Y, Z. Okay, so I only want you to react a Y. X can be free and all. Okay. Let's see if that works. 10 seconds. Come on, solver!